Great. So the absolute value is an example of a piecewise defined function. Um, However, let's just go ahead and take a look at these other two piecewise defined functions. So the first one, we really want to be able to go ahead and evaluate piecewise defined functions at different points. So remember, I guess the first thing that students have problems with is realizing that it's a function. So what that means is that we can only get one y value out for every x we put in. So for each x we put in, we have to figure out which part of the function we're using. So if I'm looking at this function here, and I'm looking at evaluating it at these 3 points, -10, -1, and 4, what I need to do is figure out, am I using function 1, 2, or 3? And it's based on this domain that we have here. So what I do first, like if I was looking for f of -10, is I figure out which function am I using there.
Now, this part I'm kind of good with because I know that would be the first one since x is less than -5.
Exactly. So x is less than -5. So we would use that first one. So we'd have 3 times -10 minus 2 is equal to -32. And then the second one, good. So the second one, since -1 is between -5 and 4, we would get the second function, which is a constant of 7. And then 4 is going to be greater than or equal to 4. So we would use that third function. Good. So we would have 4 squared plus 1. 16 plus 1 is 17. Okay. So that's good that you're able to evaluate those functions. So now let's see how we would plot a function like this.
Yeah, this is where I struggle.
Okay, so we'll do a couple of these. Let's try to plot this one. And when we're plotting this one, or any piecewise defined function, this is what I usually do. I usually take this domain and I sort of go ahead and list the interval that I'm going to plot it on down here. So here's my -5. So from negative infinity to -5, I'm going to plot function number 1. And then from -5 to 4, I'm going to plot function number 2. And from 4 on, I'm going to plot function number 3. So when we're plotting these functions, sometimes we can just go ahead and check out, what the shape of those would look like, but we do have to restrict it to a domain. So there's two sort of thoughts of process on this. So I know that another thing that you're interested in is sort of looking at the differences between the calculator you're using and the one that would be used on the exam. So I have my 84, which is something that you would be able to use on the exam. So you're going to find that this calculator is actually very similar to yours, but let me show you. So you shouldn't have to get a new one for
Okay.
practice. But the reason that 89s aren't really allowed is because they do too many algebraic manipulations, and that's really what we're learning to do. So it does sort of, simplify some of those steps unfairly to other students. One thing that you can do is you can use this for graphing though. So if I use a y equals, that's y equals here. I'm gonna maybe try to autofocus this a little bit better on the calculator. Might get blurry there for a minute, but it might come back. This one has a light on it, so it's weird with the dot cam. So if I actually put in this function, 3x minus 2, we know what that looks like. It's a line. with 2 as the slope, and y-intercept of -2, and delete the rest of this out. Oh, let me try again. 3x minus 2. And I'm just going to delete this out. And if I plot it, you can see sort of what the graph looks like there. So one thing we could do, and I don't really recommend this, is we could actually just plot the graph, and then I could erase everything to the right of that part. Okay?
Okay, this is how I've been doing it. So
Okay.
I I understand why you say you don't you say don't do it this way because it's very confusing.
Well, it's not that it's so confusing. I mean, you do have multiple graphs on there and you need to just figure out which part you're using. But I feel like it's easier to, in most cases, especially on the ends, to put it together with just a series of points because we know what the graphs look like. So what I would do instead is I know I'm going to plot this line when I'm at -5 or less. So what I'm going to do is I'm going to stick in -5, even though I know it's not included in this um, portion, it goes all the way up to that -5. So if I plug in -5 for this function, I would get 3 times -5, which is -15 minus 12, that's -17. I'm going to start there. So here's my -15. So I'm going to start with -5, -17, but I'm going to plot an open circle because I know that that point's not included.
Can I interrupt?
Yeah, please do.
Um, why do that? If I
Well,
hope that
because,
makes sense.
okay, well, I want to plot this graph, right?
Yeah.
But I only want to plot it on this interval here
Oh, okay, okay.
because it's only valid on that interval. So what I'm going to do is I'm going to go all the way up to where it's defined, and I'm going to put a point there. I know it's a line, so I know I really only need 2 points to plot it, right?
Yeah, okay.
So I'm going to go all the way up to the limit of that interval. And again, I have to keep it open because it's not included here. It's not less than or equal to, right?
Correct, yeah.
Okay. So does that make more sense?
Yes, yeah, I was just curious why you or I wasn't getting why you chose that point, but now it makes sense now.
Okay, so yeah, so I'm looking at right at the end of the endpoints of the domain. So now I know I can plug in like -6. I know that the slope is 3, so if I plug in -6, I'm going to go down 3 more. I'm going to plot that point, and that's enough for me to plot a line through there. So that's what the graph is going to look like to the left. So when we evaluated this at -10, if I kept on going at -10, I would hit -32.
Okay.
Okay, so now I need to plot something in between -5 and 4. Well, it's going to be a constant line. So it's a line with 0 slope and just 7 is the y-intercept. So that's going to be 7 through this whole thing. We know that at -1, it's going to be 7. So here's my 5 and 10. I'm just going to put my scale a little bit there. So -1, it's going to be 7. But I know it anywhere on this interval, it's going to be 7. It's just a constant function. So I'm going to go ahead and fill in this -5 here, because that's the endpoint of that interval. I'm going to go -7 all the way over to 4, and then we don't include 4, so I'm going to put an open circle there. Look good?
Okay. Yes, that one makes sense to me.
Okay, cool. So, sometimes these points get filled in by the other parts of the graphs, and sometimes they don't.
Okay.
Okay, so now the last thing I have here is a parabola that's been shifted up 1 unit. So if I was to plot this, I know that I would have my U-shaped parabola, then it'd be shifted up 1, so it would look like this, but I'm only interested in it over here. So I'm going to start again by looking at what happens at that endpoint, which is 4. Well, I've already computed that function at 4. So at 4, I have 17. So I'm going to plot that point. So at 4, I'm up here at 17, and that's going to be a point on my parabola. So I know the shape of the parabola, so it's going to be looking like this. So I should plot probably one more point. So if I plug in 5, I'm going to get 5 squared plus 1, that's 26. 26, so that's around here. So 526 would be another point, and I'm just going to go up like a parabola there. So that would be the last part of my graph there.
Okay.
Okay,
That
so it's good. With piecewise defined functions, we know that for every x we plug in, we get exactly one y out. So if I plugged in for 4, I wouldn't get something here. I would get this point here. If I plugged in -5, I wouldn't get that point. I would just get this point here.
okay.
All right. You want to do another one?
Yeah, we could.
Okay.
Just to make sure I think I understand it, but just to like make sure I do understand it.
Okay, so maybe, yeah, maybe you can walk me through this one a little bit then.
Yeah, yeah. Okay. So do we have values or
So here we don't. Here it's
okay.
just given this function, we want to plot um we want to plot this function. So I'll start you out. So I know from -3 to the left that I'm going to be plotting that line. So I'm going to plot y equals -4/3 x plus -2 from -3 on. And then from -3 to the right, I'm going to be plotting this other function, x squared minus 7.
So then from here, what I gather is that um we would take the -3 value for the first function and plug it in.
Exactly.
Okay, I've already done that, so it's 2. You can double check my work, but
Okay, let's see really quickly. Yeah, I got that too.
so we'd plot -3, 2 for the first, and it'd be open since it's included.
Okay, sounds
And then
good.
we'd
I need
want,
to get
and
up there at 2, right?
yes, yeah. And then we want
Okay,
one other point then too, right?
so -3, 2. Now this one's going to be closed because it's an equal.
Yes.
Okay, yep, we
Um,
want one other point because it's a line.
2 isn't a great one unless you wanted to point at 2/3. I'm trying to find a better one.
All
Oh,
right,
you
and
could do you
remember it has to be over here too.
right.
It has to be list. Okay.
I think we. Oh wait, no, I was going up. Sorry.
Okay.
1 second. Oh man,
I
it's
would
like
choose
pressure
something
now.
divisible by 3.
Oh, we could do 6.
Yeah,
So
negative
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 6,
6 will
-6.
work. Perfect. Okay.
I think it's -6, 6
Okay, so
is
-6, 6. Let's see here. Yeah, good. -6. Perfect. And so that's just a line, so I can connect those 2 points, right?
yes.
Okay, I'll do that.
Yes, yeah, that's the line. Sorry, I had to questioning myself for a second after I said
Yeah.
yes.
Okay, and just to sort of verify here, let's see, it has negative slope, so it is going down. It does have a y-intercept of 0, -2. That would make sense that it would cross somewhere there. Okay, so that looks good to me. Okay, and what about the second part?
So the second one, I believe it's a, uh, I think it's a parabola.
It is, uh-huh.
I'm not great at, I always, I don't trust myself, so I always plot them out first just to make
Okay,
sure, like, so that's why the hesitation's there. So I think the first point we could do is, well, 1 sec, would be -3, 2, I believe, if we plugged
okay.
3 in
Yeah,
for that.
so we know it's not defined there, but if it were, we would have -3 squared minus 7, which is 9 minus 7, which is 2. Perfect. So I'm going to go here and I'm going to make an open circle, which tells us that parabola has been filled in there. That's right. So notice that I do have this parabola. And what does that -7 do to the parabola?
Um, it shifts it down 7, doesn't it?
Exactly. So this
Okay.
point 0, 0, nice, will be shifted down to 0, -7. So we can sort of fill it in that way. And remember that parabolas have symmetry. So if the point -3, 2 is on there, then also the point
3, 2 would be on there as well.
3, 2 is on there. Awesome. So I can go ahead and sort of fill that in. Maybe not perfectly, but
Yeah, it's good enough. It's better than
yeah,
I can do.
okay. I appreciate that.